Doc, the physics of sound and music, reviewing Lab 8 for the lab exam. How is the frequency of the nth harmonic related to the frequency of the first? That would be your basic formula that you multiply by the harmonic number. So if the number is n, it's just n times the first one. So if I want the ninth harmonic, it's 9 times the first one. If I want the 31st harmonic, it's 31 times the first one. What is the wavelength of the nth harmonic if you have the first one? Well, remember, frequency and wavelength go opposite each other. So instead of multiplying, you divide. So if you have the first wavelength, if you want the ninth one for the ninth harmonic, it's the wavelength of the first one divided by 9. So you divide by the number n instead of multiplying. How do you calculate the wavelength of the nth harmonic for the string? Well, there you do two things. For the string, you have to remember that the first one is 2L. And once when you establish that, then you use the rule I explained above here. So the ninth harmonic wavelength would be the first one divided by 9. That same general principle. It just so happens to be that the first one is 2L. So the answer would be 2L divided by 9. What is a node and antinode on a string? A node is a point that doesn't move. So when that string is vibrating up and down, the node does not move. Let's go find one here. We'll go to the harmonics, and we'll click around and see if we can find something here, something wiggling. Let's go ahead and, there you go. So here, the points that don't move. This doesn't move, that's a node. There's a point here not moving, that's a node. There's a node, so that's the third one. And then there's 4, and then there's 5, and then there's 6, and then there's 7. There's 7 nodes. The antinodes are doing the maximum movement here. Here's 1, 2, 3, 4, 5, 6. This, by the way, is the 6th harmonic. You can count 1, 2, 3, 4, 5, 6. In fact, the antinodes is the way to go on that. If you have 6 antinodes, that's the 6th harmonic. And for the nodes, it's 6 plus 1. There's one extra one there for the nodes. So that takes care of what is a node antinode and where they're located. We gave an example there. What are the basic harmonic formulas for an open pipe and a closed pipe? So think about those general principles in 1 and 2. They're always true. The nth harmonic is n times the first frequency if you want the frequency, and for the wavelength, you divide by n. For the string, it's 2L for the fundamental. Now for the open pipe, it's 2L, same formula. And for the closed pipe, it's 4L. So we remember those 3 rules: 2L for the string, 2L for the pipe, closed pipe 4L for the closed pipe. So open pipe 2L, closed pipe 4L. And then you use these principles here where if you want the nth one, you divide by n. Notice that though on a closed pipe, you only have the odd harmonics. Now you have pressure nodes and pressure antinodes and displacement nodes and displacement antinodes. Now we're dealing with the pipes. And for that case, I think that what I would do in a case like that is I'd head over to your downloads here, and let's go to the pipe chapter, which is H. And let's look at this. Let's look at H here. Let's see what we got. All right, let's review these here in this chapter here. This is a nice fundamental physics for you that will help establish things. When you go to your pipe, your node, antinode nodes for the string, which we looked at earlier, you can keep the same node, antinode node, but if you do that, it means pressure. because this is atmospheric pressure on the ends, and here you get squished and stretched. So here's the antinode for pressure. So this corresponds to pressure. That may be the way to memorize that. And then you would flip it for the displacement nodes, because see here, this is a little movement here, movement on the end. So this is A and A for A for displacement. Now, if you have different, say, personality, where, I kind of like this mode also. In fact, I may even prefer this one better. My personality is probably more like this, where I like to think of this actually as moving back and forth there. So if we look at this kind of situation here, I like to think of those dashes. So my learning style, I think, is probably more along these lines here, where this is wiggling back and forth. There's a person in class standing in the middle getting squeezed and stretched. So in that case, we're thinking movement. So if we're thinking movement, then this is an antinode because you have movement, and there's a node because there's no movement. Remember, a node means you're not doing whatever you're doing there. So if it's pressure, node means you're not changing the pressure. So if you do it with displacement, then this is a node because the person doesn't move, and these are antinodes and antinodes because they're moving. And then for the pressure, you flip it. So you have two ways depending on your learning style. You can come up here and say, if I go from the string to the pipe, I can keep the same thing and go pressure. And then I flip it when I want to do the displacement. See, there's your pressure, just like the string. Or you can come over here and say, I want to work with this movement first and establish that that's no movement. That's a node for displacement, A and A on the ends, and then flip it to get the pressure. Depends on your learning style, or as I said, your personality and what you want to do there and how to remember that. So let's look at the next thing here along the chart, and that is we did that. Okay, how can you coax a string, violin string, to vibrate at the fourth harmonic? And the trick there is, all right, let's go ahead and find that. The trick there is to gently touch the string right there. If you gently touch the string right there, you will coax a node here, and if a node is there, then you'll get this wiggling, and the string will go into this kind of a mode. So just gently touch 1/4 of the way up. If you want to coax here, this to go into this mode, you would touch here, see, 1/3 of the way up, and that would be this. Here's your third harmonic in there. The other case is your fourth harmonic. What are the musical intervals between the harmonics, the ones we did in class? Well, the musical intervals between the harmonics, I think there what I would do is let's go to class, I'm going to go to class G on this one. All right. It applies to the pipes also, but if we go to class G, then I have the harmonics 1, 2, 3, 4, 5, 6, 7, 8. If I go from 1 to 2, well, that's a 2-to-1 ratio, and that's my octave. If I go from 2 to 3, that's a 3-to-2 ratio. If you put the higher one first, 3 to 2, that's going to be a fifth. So to go from the beginning all the way out to there is an octave and then an octave plus a fifth. For the octave, 2 octaves here, that means we double twice. So 1 to 2 is 1 octave and double again there. And then 5 to 4, that's a major third. So here I'm at 2 octaves, I add a third. For this 6th one here, you can do it a couple ways. One way is to look at the 4. 6 to 4 reduces 3 to 2, so it's 2 octaves plus a fifth. The other way is to go to the 3, octave plus a fifth, and if you double that, you slap on another octave, get 2 octaves and a fifth. 7 we skip, and 8 would be 3 octaves because we doubled the 2, times 2 is 4, times 2 is 8. It takes care of that, and it looks like that's the review for Lab 8.